very good morning, ladies and gentlemen. Welcome to Hydrogen Fuel Cells Europe 2022 here at Hannover Fair. I welcome you to have a seat, have a complimentary drink. We are going to discuss about something that I found quite interesting. I don't want to reveal too much yet. I have a guest speaker from the Aerospace Center, and one would say, what does the Aerospace Center has to do with hydrogen? I don't see a connection immediately, but we're going to reveal that very soon. Our topic today has a title which is Fuel Cells and Water Electrolysis, Addressing the Next Technology Challenges. For that, please welcome with me on stage Head of the Department of the German Aerospace Center, Professor Dr. Andreas Friedrich. Andreas, it's an honor to have you back here. After 2 years of a break, you're back. How does it feel like?
Oh, it feels great. So we have been one of the longest exhibitors here in this area. And so the last 2 years were tough for us because this exhibition is actually very important for us to continue our contacts with industry, with other research centers. So that's very important. And unfortunately, it was not possible in the last 2 years.
Yeah, so we are all really happy to be back here to have physical exchange and communication. And I'm also happy to be able to moderate this public forum. We have conversations every 20 minutes talking about the latest trends, discussions, and also company representations. You are here from the German Aerospace Center. And I have to say that NASA has already used hydrogen in their capsules. They use hydrogen fuel cells to power, to have electricity in their capsules back in 1960. So this is the background where we have a connection from hydrogen and aerospace. But I would like you to elaborate on that. So why are you here today from the Aerospace Center? What do you actually do, and what do you still have to do with hydrogen?
Yes, so essentially that's going back a long time already, so 50 years or so. The German Aerospace Center, of course, was very active in space research, and hydrogen is the main fuel for rockets, and therefore DLR still has a lot of testing centers for the Ariane rockets, for example, with hydrogen. So with liquid hydrogen, is one of the largest consumers of liquid hydrogen in Europe. But at that time, so we decided, DLR decided, my institution, to expand research in other areas, in the energy sector, to start renewable energies and renewable processes. And that's why they decided, okay, hydrogen technology is really a good area because we already have the expertise to handle it. And this was how research started. And then we are completely now separated from the space application. We are doing terrestrial energy research with hydrogen, fuel cells and electrolyzers.
So the German Aerospace Center, which is abbreviated DLR, is doing primarily research on hydrogen. I would like to know, because if you do the research, you know the latest trends, you know what is breaking news, and I would like you, for the audience today, maybe give some examples, give some breaking news, some information on your recent research.
Yes. So my group started around 30 years ago with this topic. So we have, as I said, we are one of the research groups with the longest tradition in Germany on this topic. We have developed many things, electrolyzers. We were the first one to demonstrate a power-to-gas system on a larger scale. So we have a tradition of a lot of innovation, and now we are demonstrating our recent projects, which are addressing the we have come a long way in the development, but there are still some technical challenges that need to be addressed, and this we are demonstrating in our booths with our exhibits. And these are, for example, going to a larger scale with fuel cells. and going to the area where, for example, aircraft need power ranges in the range of megawatt, but for that there's still no fuel cell available, and for that we are demonstrating the Balis test field, which is the first step on the way to develop a megawatt fuel cell in this area, and which we want to apply to aircraft applications.
Why is it so important to do the testing?
It is so important because there are still some challenges when you go from the kilowatt, 100 kilowatt range to the megawatt range. For example, the areas become larger, so you have to take care that the gases are distributed homogeneously over the area, that the contacting is very homogeneous, that the sealing is adequate. And another thing is also the electrical network is a challenge. So with such large currents that you have in this area, then also electromagnetic interference become very important, and you have to take measures that you avoid them. So that's a lot still to be developed.
I see. At this point, I would like to invite you to also ask questions. If you have questions immediately, let me know by raising your hand and I will come down to you. Otherwise, I have plenty of questions, but let me know because this is the chance to talk to an expert. You just mentioned that your recent project, Balis, which is a test environment for larger fuel cell applications. Can you also say in which stadium you're currently in?
So we succeeded in getting the funding 1.5 years ago, and we are in the course now of building up this test field together with partners. So we have also industrial partners, start-up companies, so spin-off companies actually, but also other larger companies. AVL is, for example, a research partner also in this area. So we are in the course of building up the infrastructure.
So are you doing the testing together with AVL and other companies, or is it already guaranteed that the larger fuel cell applications are going to be used?
So we will develop our fuel cell stack with the larger stack. So we have a parallel project where we are working on that topic. But of course, we are working with H2Fly, which is a spin-off company, with other companies in the field of aircrafts, which like Airbus also, that will use also this testing field infrastructure.
Okay, thank you. Do you have any other projects also regarding fuel cells?
Yes, so another thing that we are exhibiting is we are coordinating a European project, Nautilus, where we want also to demonstrate high temperature fuel cells, so fuel cells that operate at 800 degrees C, so very high temperatures, for ships, for ship propulsion. And this project is called Nautilus, together with cruising ship manufacturers like Chantier de l'Atlantique in France or the Meyer Werft, which are interested in a long-term development of this technology, also to the megawatt scale. However, in the first project, we are going only into the 100 kilowatt scale due to the challenges which still are present.
This is so interesting because cruise ships, especially when we have a look at the global climate change, also the scapegoat. Nobody would like to admit they're going on a cruise ship because the carbon footprint is really large. Anybody here was recently on a cruise ship? Yeah? In the future, you don't need to feel guilty anymore because this representative is working on making also the cruise ships more green. Does it mean that cruise ships would run 100% on hydrogen? Is that right?
No, the first step will be actually LNG. So this is the first step we are working on.
LNG, what is LNG?
Liquid natural gas. So right now the new ships are built on LNG basis. And we are developing the technology also on LNG basis because of it's a certified marine fuel, whereas hydrogen still has to overcome some barriers in the marine certification. However, there can be an easy shift later on. Actually, LNG is more difficult for the fuel cell than hydrogen. So shifting then to green hydrogen would be feasible.
Can I ask you something? Do you sometimes think that the hurdles in becoming a more green future, especially if we focus on hydrogen applications, is it more the certificates, because you just mentioned that, and the political framework, or is it the research and the actual components?
Well, yeah, that is always a little bit the perspective. I mean, both are important. So as a research institution, we of course focus very much on the technical challenges that we see and that we want to address. However, certification and testing is very important and takes time. And you have to, it's a more collaborative effort of worldwide effort in the marine sector, for example. And this takes time, so you have to start early in order to get also the certification ready for the applications.
Thank you. In our little pre-chat, you mentioned 2 more projects, and I'm actually, I can't decide which one I want to talk about first because I love them both. You decide. You want to talk about PEM, the titanium part,
Yes.
or the cargo bike?
Perhaps we can ask the public if they are more interested in electrolysis or another fuel cell application. Electrolysis. Okay, then I will talk. So we see here a lot of manufacturers of PEM electrolysis, and there titanium is needed because titanium is one of the metals that withstands the high potentials of the oxygen side. And we've succeeded now in avoiding titanium bulk components by coating stainless steel with titanium layers. The titanium protects the stainless steel, but it's much more inexpensive in the manufacturing. And we have published this recently, so it was a very high-ranking publication. We demonstrated a complete PEM electrolyzer without titanium core elements, just coatings.
Let me break that down. So before, titanium was unavoidable. Why was it that we could only use titanium?
Yeah, because titanium has special features. It forms an oxide layer on the surface which protects against corrosion. And other metals like stainless steel will corrode immediately under electrolysis conditions. So that's why titanium is used. However, titanium is very expensive in the forming process, in the forming of the bipolar plates of the contact elements. And therefore, stainless steel is much more inexpensive, but as I said, has to be protected against corrosion. And we succeeded in doing that.
So that is really breathtaking as well, but also breaking news in the development. I think not everyone has been notified about that. So congratulations on that success.
Thank you.
I think the industry is really happy about that. All right. Yes, there's a question from the audience. I'll come down to you.
Okay, I have the question to you as a person who knows all the trends in the market. I see in mobility that there is a kind of competition between battery cars and buses, for example, and the hydrogen cars and buses. And how do you see the future in these regards?
Well, yeah, that's always a matter of discussion. Yeah, so certainly I see both technologies as core technologies of the future. And I am a little bit traditional in this respect. I see the application of batteries in the more smaller power sector and fuel cells in the larger power sector. So when going to mobility cars, I see the city vehicle as the ideal vehicle for battery propulsion, and larger vehicles, for example, SUV vehicles as for hydrogen applications. I know that Tesla is also demonstrating very luxury cars with batteries, but you have to look at the weight of the battery that is part of the mobility. So I think from a technological point of view, hydrogen mobility for larger cars and even for heavy-duty application is the way to go. And I also see that for many areas in the world, I cannot see pure battery mobility. For example, if you look at Argentina with long distances between the cities, I've traveled there in my vacation. I cannot see that you do this with batteries because the recharging time is too long. And hydrogen just takes 3 minutes for recharging or for fueling. So I see many areas where hydrogen mobility will be favored. But however, the market will decide, and certainly there will be also a large market for pure battery mobility. No, there's no doubt about that.
Yeah, I understand that, and I think this is a view that most people share here as well. There's just not one way, but there's also a hybrid way. We've been talking about the last mile. The last mile in parcel distribution is usually the last way to distribute packages. And I want to touch upon your recent invention in terms of the last mile distribution.
So you know, cargo bikes are as an environmental friendly way of improving the inner city travel. Inner city traffic is becoming more important. And when we look at the logistic companies that are doing that, they are saying they also suffer from the recharging time of batteries. And therefore we developed a range extender for cargo bikes, which we are demonstrating in also a new European project in 4 cities in Europe, where we extend the operating time of cargo bikes by a hydrogen fuel cell system, which charges the battery, but leads to operation times of 10 hours for the cargo bike, which is what logistic operators want. And we developed the system. This is also shown in our booth. And on the larger booth of DLR, there's also a cargo bike with the system integrated into it. So you can have a look at this project.
Before I need to wrap up this discussion, I have a personal question to you, which is semi-personal, but I would like to know the German Aerospace Center, which we just chatted about, especially your department could be more called the fuel cell research, the hydrogen fuel cell research department. What do you think is your contribution, also taking into consideration that hydrogen has been moved up on the agenda of on the political agenda for global climate change prevention? What do you think? How large is the role that you play and the research that you do?
Well, yeah, so the mission that we follow is that we want to do our own development. So we want to introduce innovation into the community. That's of course our passion, yeah. But we still see that testing is very important. So they help partners also to mature their products. And help the industrial partners in collaborative projects to develop their products. So this is our agenda. So three bases or 3 important things: our own developments and innovations that we try to do, the testing for partners, and helping the industry to move forward into the
and
market.
I see that you already have a lot of partnerships and the demand is high. So actually, you don't need more partnerships, but maybe more projects that you can do research on, because so many things are happening here. And I believe, and I'm certain that next year at this fair, we will hear, and you will have 5 more breaking news that the whole industry will be influenced on. So I'm actually really happy to have you here as a representative. I can highly recommend if you visit Andreas at his booth, but also his colleagues. They have 2 booths here. The DLR is right across the corner. It's all green. They have really nice models to make it more visual, so that you can understand, so that everyone, also if you're a newbie in the hydrogen and fuel cell industry, you will be able to understand what is actually going on. So thank you so much for having you here.
Yeah.
Thank you.